Alright, hello and welcome back. So let's finish up these slides and then start some new ones. We're talking about Unix commands right now, so we just finished some of the simpler ones. And, well, it is time to write programs that involve terminal commands. So a shell script is a program that consists of a bunch of terminal commands. Among other things. There is in fact a programming language, and if you want to read that optional reading, like I think it's called Learning the Shell or something, on our Canvas page, it will help you to learn the programming language that goes behind this, but you can just put a bunch of commands in a file as well. So let's make a shell script to, I don't know, make a file and print it out. Okay, so the idea is you make a file. Normally you have an extension of .sh. That's the common file extension. But it can just as well work without any. Alright, so here's how we do it. Boop, boop. Vim. Okay, what are we going to call this? I don't know, sample script.sh, I guess. So, how are we going to do this? Let's make a file by writing to it, echo hi mom to file.txt. So that's one line. So every line is a comment, or every line is a terminal command, except for lines with hashes in front of them, which means comment. This is a comment in the shell script language. Okay, starts with a number sign like Python if you've used that before. So every line is a terminal command. Alright, so we've made the file. Let's print it out with cat, of course. Cat file.txt, and let's copy it to another file. Let's copy file.txt to, I don't know, file copy.txt. Okay, so all these things, that's how we do it. And we've called it .sh, and let's make it work. So your shell looks like this. It's called bash. Okay, I'm running a different one called Z shell, but that's not important. So your terminal looks like this, and bash is the terminal shell. It's the programming language that is behind the terminal. We can actually give it a file. We can say bash file to run our program. Okay, so I can say bash sample script.sh, and this is going to run our program and do everything inside of it, execute all the lines. Boop. So it made the file, printed it, and copied it. If I look at here we have file.txt and file copy.txt. Isn't that beautiful? So, wouldn't it be nice, though, to do // because it is a program, right? prog.sh. Yeah? We can make that happen by allowing this file to be executed. So if I do ls, I get to see all my files. If I do ls-l, I see some more information about these files. And some of these are very important. This first bit talks about permissions for this file. Who gets to read it, write it, and execute it. The first three are you as the user, the second three are your current group, and the final three are anybody else who's not you or the group that you're in. You can see what group or groups you're in with the groups command. This is all not that interesting and important. You as the user, if you want to run a file as a program, you want this execute bit to be set. And because I'm doing this in my shared folders, it's always going to be set. Okay, if I had this somewhere else, this would not be the default. Okay, so to allow files to be executed for you, by the current user, you do chmod u plus x, and then the file name. Okay? And I encourage you to read up about this. This is a bit more advanced. This changes file mode bits, and one of those bits is whether or not you're allowed to execute this program. Okay? So it just so happens that it's already set for me, but you can do it like this to set it for you, the user. Okay? So that'll set it, and there's one more thing that we need to do. We need to tell the shell how to run it. Okay? So right now, it's possible it might work actually. Let's try it. No, it actually does work. So that'll work for some shells. For others, you need what's known as a shebang. So that is where the first line of your shell script is tells you which program to use to run the script. Okay, and that is it starts with a number sign and exclamation point, and then you give the location in your file system of the program you want to run the script with. And bash lives in the bin folder, which lives in the root directory. Okay? So we give that, and we force it to run in bash. There it goes. So the above line, it's not a comment, it's a special, well, it's a special comment. It tells the shell which program to use to run the shell script. Okay, so technically you can write Python programs and be like, hey, run it with Python, please, everything that comes after this. This won't work for C++, of course, because C++ needs to be compiled, but we just made a very simple shell script that runs a bunch of command line commands. This rabbit hole goes very deep, so I really encourage you to check the that optional reading module on Canvas if you're interested in this. And of course you can ask me about it, but that I think is all I want to say here. Okay, fun stuff. Now this is going to be very useful if you have not discovered this stuff yet. So this is stuff you can do on the terminal itself, and it's very useful. So up arrow gets your most previous command, gets your most recent command. And you can keep pressing it as well. It's like up. Okay, the last thing I ran was vim sample script. Above that was / sample script. And you just keep going. Okay? That's nice. .. reruns. It's a bit faster, I guess. Then up arrow, enter. Replaced with the previous command. Okay? So it gets replaced. It's like a special variable. You can technically add to the previous command if you wanted to. You can be like, all right, cat the previous command for some reason, or echo it. Boop. So it's like, okay, echo vim sample script. That was the command that we made. What was my last command? Well, it was just that. If I do ls, 2 exclamation points, it reruns ls. Okay? And you can add to it as well. Okay, exclamation point blah gets replaced with the most recent command that started with blah. Alright, so I can say exclamation point E for my last command that started with E, which will be echo something. Exclamation point L will be my last command that started with L, which is probably ls. Yeah? That's nice. Now, the rest of these are for when you are currently editing. Well, you're typing in a terminal command. And I've been using these plenty of times, and you might have been wondering what in the world's going on. How can I move around so fast? So, Control plus the following, do the following. Control plus A is, lowercase a, is go to the beginning. I'm going to show these all in order. So E means go to end. I just want lowercase e. F, go forward, one character. B, go backward, one character. All right, and D, Control R is special. I'm gonna talk about that after I talk about these. D means delete one character, and then the alts move words at a time. Alt plus the following. F means move forward a word. B is move backward a word. Okay, so that's everything except for Control R. We're going to get to that one in a second. Okay, so let's talk about the control ones. So, the quick brown fox. Control A, go to the very beginning. Control E, go back to the end. Annie. Let's see here. B, Control B to go back a character. I don't have to move my my fingers to the arrow keys. B and F to go back and forward by characters. Let's see here. And then delete, or D for delete the current character that's under your cursor. So Control D will do that. Okay, and I guess there's also Alt D as well, which deletes the current word. So Alt plus B goes back a word at a time. Alt plus F goes forward a word at a time, and Alt plus D deletes a word. Okay, that's very helpful, I think. And then finally, Control R starts a search. Starts searching your previous commands. Keep pressing Control R after typing a query to see more commands that contain that query. So if I want all my ls commands, or all my echo commands maybe, I can say Control R and start typing echo. And it'll go to the first one that it found in my history. I can keep typing Control R to go to previous echo commands. And apparently there were no others. Okay, so Control R, L, will give me ls, sample script, ls again, sample script. If I type all of ls, I can see that I did lsa, lsl, all that stuff. So isn't that cool? Okay, yeah, that's useful stuff, I think. Let's see here, a few more and that's all. We know how to move around with cd, changes your directory, of course. And you have those special ones like ... for your parent directory and things like that. There's also a stack of directories. And you can see them with the dirs command. So dirs -v shows you all the directories in your current stack of directories that you've been using in your terminal. I only have one right now, but let's go to the desktop and push D a new dir. Okay, so push D my desktop. Ooh, isn't that nice? And now I'm suddenly in my desktop. That's my current directory. And though I have a stack of directories built up now, so I can get to both of them now, I can pop D to remove my top directory from the directory stack. So I'm done with my stuff in the desktop. I want to go immediately back to where I was before. It'll take me back to the new top of the stack after removing desktop. So that's a good way to like move around on your file system. It's like tabs almost. So that's very nice. If I push desktop again now, dirs v, to see my current directory stack, there's more than just that. You can do push D or pop D with a plus sign. Oh darn. Well, the idea is help. Yeah. Cool. It will rotate the stack in a little bit, so that you can move around to directories. Okay. Plus n or minus n. Usually you use plus n. So if my directory stack looks like this, and I want to save the fact that I was in the desktop, but I want to go to my lecture 25 folder, I can say push D plus 1 to shuffle around the stack by 1. So now, this is the order that is the stack. If I had 3 things, it would shuffle them all around, one by one, and wrap around. So that's how you can move around and keep your history. That's very nice. Okay? Go to shuffle the stack by n, making element n stack directory n the new current directory. Very fun stuff. Okay, 2 more, and then we'll go to the next topic. So wget stands for, actually I have no clue. I think it's webgit, something like that. So what it does is it downloads something from the network. So you can give a URL and it'll download a file. So like you can say wget https, like you give it a file like foo.com/file path/file name .zip, and it'll download file name.zip. So you can access the internet technically without ever going on a browser. That's wget. And then the final thing is wildcards. So if you use the star in, I'll just say it like this, if you star in any of your terminal commands, it gets filled in with everything. So for example, it can be used to fill in file names. So think of the star as like a hole. And the terminal will fill in that hole. With every possible value that might fit. So for example, I have two documents in my current directory that start with file. So I can say file star, and if I just echo what that does, like what does this become? File star to the terminal after I press enter becomes both of those file names that started with file. It's like file, and then fill in the rest for me, please, with everything possible. So, file star is every file in the current directory that starts with file. star.txt is every file that ends with .txt. This is going to be very useful to you, I think. Star is every file in the directory. Almost every file. It doesn't include hidden files, but that is, you can get around that if you'd like. So yeah, every file, echo every file dot sh. And so you can give to G++ and be like, G++, please, every .cpp file in the directory. That's useful. Okay, so that's what I want to say about wildcards. And so that is a crash course on the terminal. I know we don't have a ton of time to talk about everything, but if you're curious about any of this, please come and yell at me in office hours or on Piazza. So some final exercises. I do encourage you to try those exercises yourself on LeetCode. They have a ton. They're very helpful for like getting jobs because everybody gives you those silly kinds of tasks to do. And then I also encourage you to write a shell script to submit your lab, to wait 15 minutes. There's a sleep command that you can look into. Sleep 5, sleeps for 5 seconds, and then download your grades and view them. Okay, so that is totally possible with your current knowledge. So good luck with that, and let me know if you have any questions. So with that, I want to move on to the next set of slides, and this one is fun. It's about a topic called inheritance. It's the final piece of the object-oriented programming puzzle. Okay, we've been talking about many things, but there is one that I've been keeping you in the dark about, and it's time to bring it into the light. So let's start. So here is my beautiful cat. His name is Alonzo. I want to represent him in code, in a file, in a programming language. Okay, so I'll make a cat class. He'll be an object of that cat class. All right, so I'll have it, give it a constructor, be like, okay, it takes 3 things, a name, an age, and a favorite food. Cool. So when I declare Alonzo, he will be given his name. His age is currently 0 years, and his favorite food is, I do like giving him tuna sometimes, and he tends to like it. So let's say that. He'll have a talk method that says meow, because he's a cat, of course. And then you have plenty of getters and setters. And you have your private member variables, so your data associated with every cat. So every cat has a name, it has an age, and has a favorite food. Okay, that's a cat class. I think that is not too bad to wrap your mind around. But how about a dog class now? Okay, so let's introduce that. So here is Victory, the mascot of Fresno State. I think he's in like his 3rd reincarnation or something. One of those. They keep replacing him, which is a cute little tradition. So yeah, his name is Victor E, and he lives at Fresno State. So maybe every dog class that I make should have a name, an age, and a college associated with it, because every dog is, of course, a mascot for a certain university. Okay, so let's say that every dog has those things, so I'll use the constructor to fill in that stuff. So when I declare Victory, I will give him his name, his age, and his college, his Fresno State. Okay? I will give him a custom talk method. Okay? That prints out the standard thing that we think that he says, because he totally speaks English. He says go dogs go whenever we ask him to talk. And then we have, again, more getters and setters, because we're good object-oriented programmers. And then finally we have the data associated with every dog. Okay, so you might be thinking, I see a pattern. Okay, so what is the pattern? The pattern is duplication. All right, so what would you like to do to solve this duplication? Pause the video and think about this, because this is going to lead to inheritance. Is there anything you would like to have? Okay, so if you stare at this long enough, here's something that I would like to have, maybe. The fields, or the properties associated with cats and dogs, there is some overlap. Do you see that? Name and age overlap. The only different thing is the college here and the favorite food here. Okay? In addition, both of these classes have a talk method. They just do different things, okay? They're both called talk. They just do different things. You see that? So wouldn't it be nice if we didn't have to duplicate so much code when a lot of it's the same? Like, consider the getters and setters. Get name and age. We have to re-implement those. Okay? So that's no fun. That's a problem. So enter this concept now called inheritance. So the idea is, well, cats and dogs, they share a lot of information. That is the key. That's when you notice that we want inheritance to be a thing now, because they are both animals, of course. So a cat's an animal, a dog's an animal. What if we, now this is a big if, and this is the key, so what if we make a third class called animal, okay? And we'll have cat and dog, what's called inherit from it, okay? So there is going to be shared pieces of each in this animal class, and cat and dog are going to inherit from it. And this is a diagram that's an inheritance diagram. So you read the arrow as cat, the start of the arrow, inherits from the end of the arrow. It's also called an is-a relationship as well, because a dog is an animal. A cat is an animal. And so inherits from and is-a are kind of the same thing, okay? So keep those in mind. In most cases, they're the same. Okay, so we want to reuse code with this fancy topic called inheritance. Okay, so the idea is, here's the actual definition of inheritance. It's when you have a class and you base it on another class, and this allows you to reuse code, okay, which is really nice. That's what we wanted. We don't want to make all these getters and setters a million times, okay? We want to understand the fact that these two things have talk methods that can be shared. And there's a bunch of terminology now that we need to get up to speed on. It's called a derived class. That's one of the ones that, those are the classes that inherit from the other ones. So cat and dog are derived classes because they inherit from a base class called animal. Okay? And these have a bunch of different names. A base class can also be called a superclass or a parent class, and a derived class can also be called a subclass or a child class. I will use all of these interchangeably, so I'm sorry, but it is just something that hopefully is intuitive and you will get used to, I promise. And if we have things from the animal class that change, we can override them, and this is very, very powerful. So we can maybe give an animal even a talk method and override that. All right? So I have to go have a meeting now, but I will be right back to show you exactly how to do this stuff. Okay, it is time to go and implement all this stuff using this fancy thing called inheritance. So what in the world does inheritance look like in C++ now? Yes, it is recording. Okay, so here's what we do. We're going to make our animal class, just as we did. And it's going to hold all of the shared stuff, okay? So shared data goes here inside of the animal class, so we don't have to duplicate it in any of its subclasses, because remember that cat inherits from animal, and so does dog, okay? All right, so an animal is going to worry about just the shared stuff. Okay, so we're going to use the constructor to set the shared stuff. Sets. Let me write that a little bit better. Sets shared stuff. We're going to use a talk method inside of animal just so that we know that every animal always has a talk method. We'll just say something generic like animal noise, and we'll override that. But it forces it to always be present in any animal now. We'll usually override this. It's useful because now we know anything that inherits from animal has a talk method. Okay, so then we have the getters and setters once and for all. And these will get shared with the subclasses. Which is beautiful. And then, suddenly, we don't have as much work to do when we make our dog class. So here's how you say, I want to inherit, please. This line right here is saying that dog inherits from animal, okay? You say class dog colon public animal. And this part I'm going to explain on the next slide. But you say public before animal. So just pretend this wasn't there for a second. Saying that dog inherits everything from animal, okay? We're adding to it. And so now in the dog constructor, we take all the things that a dog needs. It still needs a name and an age and a college. But we let the animal part of the dog, because every dog is an animal, we call its constructor inside the initializer list. This is very important. You have to put it here. So we construct the animal parts of the dog using animal's constructor. Okay? So that's how we let the animal part worry about the name and the age. And we'll worry about setting the college. That's what we manage because that's the one new field. You see that? That's all we have to worry about now in dog. And then we can override our talk method. And really, I should put the word override here. But we'll talk about that in a second, maybe in next lecture. Which is beautiful. Okay, and then we have our getters and setters just for the college part, just for the one new thing, because we inherit all these other ones from animal. We can still use them. Okay, so let me show you this in code. So what I've done is I've implemented the animal class, as we said. It's got a constructor, it does everything we thought. This is the generic talk method. And then down here I've implemented dogs. They inherit from animal publicly, we say, and it does all the same stuff. We override the talk method. Only worry about our new getters and setters and our new fields, and then all the same stuff for cats. And now, in main, I can be like this. I can say, all right, make a dog. What's his name? Victor E. And he has a name. It is Victor E. His age is 3 and his college is Fresno State. And suddenly I can use animal things of Victor E. I can say cout Victor E dot all these things, get name. That lives in the animal class now. You see that? I've inherited that stuff. All the subclasses get these. So I don't have to duplicate them. I can say get name, get age. Okay, so here I go, I'm getting name of Victor E. Okay. And this is not implemented in the dog class, remember. So I'll say inheritance -o inheritance. Bam! We're calling animal methods on a dog. It's beautiful. All right, Victor E's full name I think is Victor E Bulldog, so let's set that. We'll say Victor E dot set name, which again lives in the animal class. Please set that to Victor E Bulldog. Okay, and then reprint the name. So the setter works just like it should. Beautiful. This is really cool stuff. Its inheritance is very useful. Then finally, we can call stuff that was in the dog class, of course, because that stuff also exists in a dog, obviously. we can get the college and set the college, or talk. Okay, so we can say Victor E dot talk, and he'll say, go dogs go. Beautiful. Okay, so I can do the same for Lonzo. Be like cat Lonzo. His full name is Alonzo. His age is 0. His favorite food is tuna. And I can say Lonzo.talk. And this is an overridden talk method. Oh, oops. I copied this and didn't paste it properly. He says meow. He's supposed to say meow. My bad. There we go. So he says meow. And so we've overridden the talk method in cats as well. Okay? So see how this is all useful? Like, I don't have to rewrite get name and set name. It just works. Okay, so that's implementing dogs with inheritance, and cats as well. What in the world does that :public mean? What is that? So what it does is it controls the access over the inherited items. So it forces them to be inherited as they were. :public means inherit everything with the same access specifier. Okay? :private means inherit everything and force them all to be private, even if they were public. Force everything to be at most private, and private is of course the lowest option. All right, so this is technically force everything to be at most public. So :private, for when you inherit privately, everything that was public now becomes private. Okay, so if I inherit cat, how about if we inherit dog from private animal? Now, all the inherited stuff of animal that was public becomes private. This is not something that people normally do. You usually always use :public. So I'm not going to spend too much time on it, but we're going to get compiler errors now, because everything is now private. Okay? Get name, we've inherited it from animal, but even though it was public in animal, we've made it inaccessible because by inheriting privately, we've restricted access to only the dog class now, because this stuff is private to it, can call those methods. Okay? So maybe you want to rewrite it with a new name or something, but you can't access them anymore. Okay? So normally, most people do :public. And there's going to be another one called :protected, and that's going to mean exactly the same thing. Force all inherited stuff to be at most protected. And I'll talk about that in a second. So that means anything public becomes protected. Anything protected stays protected. Anything private stays private. Whereas this, :private, made everything that was public private, everything that was protected private, everything that was private stays private. And just for good measure, :public means everything that was public, still public. Everything that was protected, still protected. And I'll talk about what that means in a second. Everything that was private is still private. So normally we just want to keep everything as it was. Sometimes you want to change it. Very, very, very rarely though. Okay, that's what the colon public means. And so now let's take a second to stop and remember our terms. So I've talked about derived classes, subclasses, base classes, superclasses. Here is a new diagram. I've made an animal class, and okay, I've made cat and dog and bird inherit from that. And then I've also made a special kind of bird, because you can have inheritance of inherited things, of course. Because a penguin is a special kind of bird, and a bird is a special kind of animal. You can have hierarchies now. It's beautiful. So the idea is, I have all these things. An animal, or a cat is an animal, a dog is an animal, a bird is an animal, and a penguin is a bird is an animal. So please count how many derived classes you see and how many base classes you see. Okay. Assuming you have unpaused the video now, let's see what the answers are. So a derived class is anything that inherits from something. So cat inherits from cat inherits from animal, dog inherits from animal, bird inherits from animal, and penguin also inherits from bird. So everything that inherits from something is a derived class. So I see 4. Okay, that's how you do it. And how many base classes are there? A base class is anything that anybody derives from. So animal is being derived from by 3 things. And you got to catch this. It might be a little not obvious, but bird is also being derived from. So bird is itself both a derived class and a base class, depending on the perspective. Okay, so there's going to be 2 base classes. Okay, hopefully that makes sense. And then finally, let us, or not finally, but maybe finally for this lecture, let's talk about static versus dynamic dispatch. So these are just big words, but don't worry. There's going to be a bit of a problem. I would like to use animations and hide these, but it's too fun to just show them now. Okay, so what happens if we try to call the talk method on an array of animals, /vector? So one really nice thing about inheritance is you can treat things like the base class. Because they do have everything that exists in the base class. That's very powerful. We'll see. So the idea is this. Here I can make a vector of animals. I can force cats and dogs to pretend that they're animals, to just get the animal parts of them. V equals Victor E and Lonzo. So this is beautiful. I gotta include vector, of course. Here's the idea. I can make a vector of animals and put derived classes inside, because every cat is an animal, every dog is an animal. It's beautiful. It's one of the very nice things that inheritance gives you. So I can treat everybody, I can treat a cat like an animal and just call the like an animal and just call the animal parts. So from the vector's perspective, we're dealing with animals, but that's fine. We can use the getName, setName, getAge, the talk methods, things like that. So what if I wanted to call the talk method on an array /vector of animals? So here I go. Boop, boop, boop. What would you like, right? What would you like to see right here? So for animal, can make it be a constant. Const animal a in v, please a dot talk. What would you like to see? I think you would like to see go dogs go, followed by meow. Yeah? Oh. we get animal noise twice. I should section this off with an empty line, but what in the world? We don't want animal noise twice. We want to see go dogs go and meow. That is not at all what we wanted. But there is a way to make this do what we want. Okay? We want to, it's a combination of the virtual and override keywords that I'm going to talk about. The idea is, even though a cat and a dog is an animal, to C++, without any extra help, it's not sure what's going on. It doesn't know whose method we want to use. From C++'s point of view, we wanted to call the animals .talk method. Okay? That's no fun, because cat and dog have an overridden one. So C++ by default, it will take this one. We have to tell it to do otherwise. To do the more obvious thing of, hey, this is a subclass, we've overridden these things, please use these instead. And that's what the virtual keyword gives you. Virtual to C++ is equivalent to saying, please use these derived class methods instead, please. So I'm going to go have office hours, and then I will be back to give you an example of all this stuff. All right, nobody showed up to office hours yet, so let's get this done. Let us add virtual and override to our talk method. Dun dun dun. So this is all you have to do. Virtual void talk, you say it up here. The base classes method that you want to override is marked as virtual. It's like, virtual, it's not real. It'll change, maybe. And then we say, void talk const override to say, hey, use this one, please. Technically, you don't have to include it, but it's a good strategy. We say void talk override. So you don't need the virtual anymore. C++ already knows this is virtual, but it's good practice to include the override. This will help it catch errors, and it'll also help the users of your library. And then there is one last thing that you need to do to get this working. It's to change this from a vector of animals to a vector of animal pointers. Okay? So unfortunately, this is required, because otherwise it does some horrible thing called slicing. But you can make a vector of animal pointers and put derived classes inside. And this will force it to do the right thing now. So it's not any of this anymore. So we say a arrow talk, and this is now going to work. Go dogs go and meow. Wow. So all it took was virtual void was the virtual and then the overrides. Technically the overrides are not necessary, but it's good practice in C++, like I think 14 and onward or something. And then you need to use pointers, because if you just use animals, it'll chop off the parts that are necessary to remember, hey, this was really a cat, hey, this was really a dog. But pointers will work, and yeah, that's about it. So also have to use pointers in your array / vector. Dun, dun, dun. There we go. That is the secret. All right, so let's put these all into words now. So a virtual method, it's one for which the subclass's implementation should always be used, regardless of the type that's being used to store the object. So if you have a vector of animal pointers, and star v at 0, it's really a dog, the virtual talk method will force v at 0 arrow talk to call dog's talk method. Okay? And the same for v at 1, if it's a cat, it'll force it to call the cat's talk method. If you do not have the virtual bit, suddenly it won't work. And then the override doesn't make sense anymore because it's not overriding anything. So without those things, it just won't work, even if you use the pointers. Okay? Undo, 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 undo. So that's what virtual gives you. It forces it to do the thing that you think is obvious, but to C++, it needs some extra encouragement. Okay, so that's all I want to do for this lecture, and I will see you in the next one.